Uh, Hello all. My name is Murali Krishna Bomisetti. So today we are going to discuss about travel algorithms. So here are our group members: Ade Kunli Salahuddin, Ayodhya Vijayendra, Mahesh Chittimalla, Murali Krishna, Vinod Kumar Reddy, Nanda Kishore, Sai Kiran Belli, Sri Hari Venkata Sivanagi. Can you go to next slide, please?
Yeah, sure.
So here we are going to discuss about search algorithms. So search algorithms are divided into uniform search and informed search. So here we are going to discuss about depth first search, breadth first search, and uniform cost search. And after that, in informed search, we have greedy search, A-star search, and graph search. What is here introduction? What is graph traversal? The technique for finding a vertex in a graph during the search process is called graph traversal. Graph traversal is also used to determine the order in which it visits the vertices. Can you go to next slide? Yeah, from here my teammate will continue.
Hi, thank you so much, Murli, for giving the brief introduction about the project and the whole thing, and what we like to do about the remaining next 20 minutes. We like to learn about all the teammates, and now I'll go with the travel map. And we basically know about that the graph application that involves in the particular orders of the vertices and the interaction based on the graph topology. And the graph traverse is also similar to the tree traverse. And for the algorithms of the graph traverse, it begins with a single vertices and also begins for all the remaining vertices on the nodes. And the graph is also deals with a variety of the challenging situation. And for the algorithms, it begins with the vertices. And whenever the graph is not connected, it's can't able to reach all the vertices. And for the in the graph traversal algorithm for only one and every node in the algorithm it's connected only one time, and the graphs are divided two types. One is for the uniform sets and the informed sets. Just I'll give a brief intro about what is what and the uniform and informed sets. And the informed sets is the technique that it couldn't use any additional information from the current state to for the destination, as well as for the informed sets it used some additional information to reach the current to the destination state. And there are some similar differences there for the uniformed and informed set. And and also I'll explain about that why we are using the informed and the uniformed sets, because means it tells you the knowledge for that to reach the goals, and also for it's always complete the final destination. But like to be informed sets, it may or may not. Means it doesn't give 100% guarantee to reach the destination. And the cost also very high for the uniformed sets when compared to the informed. And there's the examples are there for the uniformed and informed sets. And you can also see that in the previous slide. Kiran, can you please go for the previous slide?
Yes, please.
Thank you. Yeah, here that they're divided in two types, like uniform in the categories like in the uniform sets for the depth first sets, and the breadth and the uniform cost, and the informed sets like greedy and the A-star and the graph. And and the next, can you go for next slide?
Yeah, okay.
Yeah, sorry. The next for the algorithm for the sorting depth first test, one of my teammates Ayodhya will continue the depth first algorithm, and now I'm handled to Ayodhya.
Thank you, Vinod. I will go through the next couple of slides with you, which talk about the depth first search algorithm. So here we will be in this algorithm, we will be going through from a starting node to the ending node in depth-wise. In the other searches, we will think that once we determine if there are two nodes, two adjacent nodes, we will be traveling to both or like multiple next nodes. Instead of doing that, in this particular search, we will be going to the going next, after we selecting one node, we will be going downwards until we reach the end of that particular tree. But after we reach the end, we definitely have, it doesn't mean that we travel through all the nodes. So we have to do the backtracking and go backwards, and then we have to travel through the rest of the nodes. Let's move to the next slide, please. So moving to the next slide, we will be talking about the how we build the depth first search algorithm. So here in this example, we have used the Java language in order to implement that. Instead of installing all the Java platform in our local machines, we have used the online Java IDE to write our algorithms. So how this, if I talk about how this algorithm works, is we first declare the number of vertex. So according to the size of the number of vertexes we have, we created the linked list. Inside the linked list, we will be able to store all the nodes according to the way we are traveling through. So once we have all nodes in the linked list, we will be picking we can pick the random nodes, or we can start with any particular node to start our travel. Once we pick the node, we will be adding that into the stack. So as we know, in this stack, we will be doing the first in, first out, so last in, first out method. So once we have the first node in the stack, we will be pulling popping that out, and we will be adding that to closed list because they're on a closed list. And the same time, we will be looking for if there are any other adjacent node to that particular one. If there are any, we will be adding those nodes to the stack. But before we add, we have to make sure that the nodes we are trying to add is not visited already. So in order to make that decision, beginning of the algorithm, we will be maintaining an array to store that information. If node is visited, that information in the sense like if node is visited, we store the Boolean value to mention whether it's stored. If it's stored, we'll store true. If not, we store false. So that way we will be not visiting the same node multiple times. Let's move to the next. So here we have a list down couple of advantages of this search. Algorithm we have known so far. So it is taking very less CPU time, but it has a disadvantages when it's come to the time complexity. Because it will be traveling through all the entire depth of the entire tree, and then we will be backtracking to go to the next traversal node, the next nodes. And also the biggest disadvantage is it doesn't guarantee even though if we reach to end node, it doesn't mean that we reach to our goal node. We have to do backtracking and come back, and finally we have to use the next path. And maybe that path is not even the end goal, we have to go back. So this is time consuming process. So I wouldn't say this is the best search if we have a limited time and if we have a huge graph to travel through. If we move to the next slide, we have a screenshot of one of example we have done. In this example, we choose node A as a starting node, and we travel through end of the node G. This point onwards, my other team member, Kiran, will continue. Thank you.
Thank you, Ayodhya. So yeah, going to the breadth first search. Breadth first search, it's an algorithm for tree traversal or graphs or tree data structure. So basically BFS, which is known as a breadth first search, can be easily implemented using recursion and data structures like queue, list. So it's BFS, it's like a traverse the graph systematically level by level, forming a BFS tree along the way. If let us consider if we start our search node from node V or like a node A, the root node of our graph or tree data structure, the BFS algorithm will first visit all the neighboring nodes of V or A, and then later its child nodes level 1 in the order that is given in the adjacency list. Next, it takes the child nodes of those neighbors level 2 into the consideration and so on. This algorithm can be used for both graph traversal and search. So when searching for a node that satisfies a certain condition, target node, the path will be the shortest distance from the starting node to the target node. The distance is defined as the number of branches traversal. So yeah, you can see over here, like it is possible to locate any node in the network that can be accessed from the starting point using the BFS. So this is one of the point. So, and also like BFS, coming to the next slide, you can see over here. This is like how we develop. So the structure we develop using the algorithm, using the queue in Python 3, and we use the Jupyter notebook. So generally the algorithm works as follows. So initially, like it choose any one node randomly, or like the node we have been given to start traversing, and we convert it. Then later it visits the adjacent and visit nodes, like its child or its neighboring nodes will be visited, and we convert the entire tree or the data which we have been given to us into the two-dimensional array or 2D array structure. So you can see over here, once the node is visited, it is marked as visited and convert. Once it's visited, you can see over the convert the input data into the form of 2D array, like the graph is converted into two-dimensional array. So yeah, the visitor node is added into the queue, and if there is no adjacent node, then it will be removed from the first node from the queue. So basically, BFS it follows the first in, first out, or like last in, first out. So this procedure will be repeated until the queue is empty. So coming to the advantages, so the solution will definitely found out by BFS, if there is some kind of solution. So definitely the solution will be finding out. BFS will never get trapped in a blind alley, which means unwanted nodes. If there is more than one solution, then it will find a solution with minimal steps. So there are few disadvantages as well with BFS, like a memory constraints, memory limits. It throws all the nodes are present a level to go for the next level. If a solution is far away, that consume times, like it is really long, so the node, then it will definitely gonna take time to reach out to the goal. And coming to the applications, so like few of the applications of BFS are like finding the shortest path, and like checking a graph with pettiness or like smallness. And the other one is like BFS algorithm. It's like a copying of Cheney's algorithm, which is an algorithm used for sorting out the path. So next, going to the code output, like you can see over here, we converted the input data into the two-dimensional array, and we use the queue over here for the data structure of queue has been used in this, and okay, like whatever the visited array, it will be stored into the queue, and the unvisited will be visited and adding into the queue until and unless like the entire nodes are visited, and the optimal path will be output will be getting from over here. Thank you. Going to the greedy best first search, one of my colleagues here will be explaining about this.
Yeah, thank you, Sai. And coming to greedy best first search algorithm always selects the path which appears best at the moment. It is a combination of the depth search and breadth first search algorithms. It uses the heuristic function and search, and also allows us to take the advantages of both algorithms. And the best first search starts in an initial start node and updates neighbor nodes with an estimation of the cost to a goal node, and it also selects the neighbor with the lowest cost and continues to expand nodes until it reaches the goal node by using priority queue. And coming to next slide. And here, by using Python, we developed a greedy best search algorithm by converting the input data into form of 2D array. Now my marketing the initial node and push it in the queue, and in visiting the node with the low heuristic value by repeating the steps until the goal node is reached and the optimal path is found. And coming to next. And coming to advantage is more efficient than breadth first search and depth first search algorithms, and also can switch between BFS and DFS by gaining the advantage of both algorithms. And as will coming to disadvantages, it can get stuck into the loop, and also it is not optimal. And next slide. And this is the code output which we run in the Python by using Jupyter, and will be continued by my friend Mahesh.
Hello everyone, this is Mahesh, and I'm going to explain about A-star search algorithm with some advantages and disadvantages. Here is the first slide. Like A-star search algorithm finds the shortest path to the objective state by using the heuristic function, and this strategy searches low-cost solutions and leads to A-star search. The star in this A star represents the optimality, and when there is a switching between the states, it will be identify the least expensive path in between them. And A star is an informed heuristic search technique, and its ultimate goal is minimizing the total cost path. And here is the function provided, like f of n is equal to g of n plus h of n, where f represents the total path cost and g represent it gives the actual cost incorrected in researching the node, reaching the node. H represent it gives the estimated cost of the path from node to the goal state, and n represent node. Coming to the next slide. Here is the algorithm for A star, where we developed A star search algorithm in Python by using priority queues and array. The requirement to run this code, we used like Python 3 and Jupyter Notebook. There are a lot of different ways to implement this algorithm. Mostly this can be implemented with the priority queues or by sorting the list of open nodes in ascending order. It is important to select a good heuristic to make A star fast in searches. A good heuristic should be close to the actual cost, but should not be the higher than the actual cost. Here are some steps to the algorithm, how it works. Firstly, converts the input data into the form of 2D array, then start or mark the initial node and pushes into the queue. Now calculate the adjacent node f of n value and visit the low cost node. Finally, continue to repeat the above steps until the goal is reached. In the next slide, there are some advantages and disadvantages of A star algorithm. Coming to the advantages, this A star algorithm is excellent and it is most efficient method. It will be helping challenging the task, and no other algorithm guarantees to expand fewer nodes than A star. The disadvantages are like a finite branching factors and constant cost per action make this method complete. The speed of the A star search is determined by heuristic approach used to complete h of n, and it has complexity difficulties. Coming to the next slide, there is a output and found the path for A star search from node A to n node G. So A star search algorithm is basically a combination of uninformed cost search and greedy best first search algorithm. As we add up the values of both heuristic function and cost function to find out the nodes to be accessed, A star search algorithm uses like for finding out the path in which the nodes are being accessed after starting the starting node. We check the least cost to access a particular node by calculating the function value, by adding the heuristic function to access the node, and the cost to access the particular node. If the overall function value to access to adjacent nodes is the same, then we will access the node in ascending order. This process is continued until we access the goal node or end node. And the output we got when the starting node is A is like we can see that in the output. So that's it, and the rest of the part will be continued by Salahuddin.
Thank you very much, Mahesh. That was a very good presentation. I'll be taking over the uniform cost search, and I would like y'all to know that uniform cost search is an uninformed search algorithm that uses the lowest cumulative cost to find a path from the source to the destination, which means the nodes are expanding, and it starts from the root according to the minimum cumulative cost. And also the uniform cost search is then implemented using a priority queue. So the search is, like I said, such an uninformed search algorithm since it operates in a brute force manner, and the algorithm can be used to find the path with the lowest cumulative cost in a weighted graph where nodes are expanding according to the cost of transversal from the root node. In the next slide, we'll be talking about how we develop the uniform cost algorithm. So we developed the uniform cost algorithm in Python using priority queue, and the requirements of developing this algorithm is we have the Python 3 and the Jupyter notebook. So the algorithm for uniform cost is it goes by converting the input data into the form of 2D array. We insert the root node into the priority queue, and repeat while the root with the queue is now empty, and also remove the elements with the highest priority. And if they removed node is the destination, then we print the total cost and stop the algorithm. So, and we continue to repeat these steps until the goal is being reached. So as the first step, we will be inserting the root node into the queue. Then we will remove the element till it's empty, like I said. And the root node is the starting node from the path, and the priority queue is being maintained to maintain the path with the least cost to choosing for the next transversal. And also, like, just to shed more light for what's a priority queue. Like what is a priority queue? A priority queue is an advanced type of queue data structure, which is instead of dequeuing the oldest element, a priority queue sorts and dequeues element based on their priorities. And a priority queue is commonly used for dealing with scheduling problems, and it gives precedence to tasks with higher urgencies. So I'm going to the next slide. Before we go to the output, the uniform costs have some advantages, which is it has some advantages, which is it gives maximum priority to the lowest cost cumulative to the lowest cumulative cost, and uniform cost search is equivalent to the BFS algorithm if the path cost of all edges is the same. And the uniform cost search is optimal because it's at every stage the path with the least cost is chosen. And there's some disadvantages as well, which is it does not care about the number of steps involved in searching and only concerned about the path cost, and due to which this algorithm may be stuck in an infinite loop. So now we'll be taking a look at the output of the code, which is right here in the presentation, and there's more of it in the documentation as well. We put all the using the 2D array, the priority queue, and we gain our output right here. And also I will be handing over the conclusion part of the whole presentation to my colleague right here.
Yeah, thank you, Salahuddin. Hi, this is Nandakishore.
And coming to the conclusion, during this project, we talked about that the concept and advantages and the disadvantages of different graph search algorithms, such as depth first search and breadth first search and uniform cost search, greedy first search, and as well as the A-star search algorithms. And we also talked about how they work and how they are used. And using that, we also have the outputs for all the search algorithms. And the graph search algorithms help you and your computer friend move through a graph dataset in the fastest way as possible. And not only that, it helps to get the good outputs, as we already seen in the previous algorithms. It's already given. And yeah, thank you each and everyone.
This meeting is being recorded.
Before conclusion, we'll be going through a brief code review. So like what type of data structures we have been used in this 5 algorithms. So my friend like Ayodhya, she will be explaining regarding the DFS algorithm. Yeah, Ayodhya.
Thank you, Kiran. As we discussed earlier during the presentation, we have used the Java and this online IDE platform to implement our algorithm. So here we start with start by creating a class. We name that as a DFS linked list, because in order to store all the vertexes we have in the graph, we use a linked list. So int vertex variable will hold to the number of vertex we have in the graph. And the link second line, we will be creating the empty linked list. And the next method is the constructor for this particular class. And we will be accepting the number of vertex as the parameter. And then we will be storing that information in the class method. And at the same time, we will be creating the new linked list. And also this next line, you will be seeing the for loop, which we use to travel through the adjacency list that we will be inserting data in later in the main program. Next method is insert to linked list. This method has been used to add the relationship between one node to another. So all the nodes connected to each node are connected to next node with edge. So we will be storing the edge value as well. We call it as a weight. And the next method is the actual, the method we really concern about, which is generating the DFS algorithm. Here we will be accepting one parameter. That parameter will tell us which node to be start with. And next we will have a Boolean array that used to store whether that particular node is visited or not, because that will be important going forward, not to visit the same node multiple times. And then we will be initiating to create a stack. And then once we create the stack, we will be pushing the first vertex, our starting starting vertex into the stack. Through this while loop, we will be checking if the stack is empty. If it's not empty, we will be doing the peek. Peek means we will be getting the first, looking into the first element of the top element of the stack, and then we will be popping up that element. After we popped it, we will be checking if that particular vertex has more, if it's visited. If it's not visited, we will be printing the path. In this example, we have created a method called print path method that you will be seeing that later. Once if it and also we will mark that particular vertex as visited, and then using the for loop, we will be traveling through all the entire adjacent list to make sure if all nodes are visited. If not, if it's a new node, we will be pushing to the stack, and this while loop will run forward until we empty the entire stack. Print path is nothing but just the print out a statements to it will have the particular mapping to int value to the actual printed node name. If you scroll all the way down, we will have the main program, which will be used to call all these methods we have declared earlier. the first line, we will be creating the linked list with size 20 because we have 20 elements. And next, we will be inserting all the edges and the vertices into the linked list. And finally, we will be calling the method we have created earlier called generate DFS to generate the algorithm. So here in this example, we pass the node A as our starting algorithm, and we will be seeing output traversal path as below. Thank you.
Thank you, Ayodhya. And basically, the rest of the algorithms was developed in Python using the Jupyter notebook. So coming to the BFS algorithm was developed using the queue and the array. Basically, the input nodes, whatever we took, is been firstly converted into the two-dimensional array, 2D array, so which is nothing but a grid matrix. So, and then later we defined or we created a function which is nothing like a BFS, where we'll be giving the array and the visited array and the start node as the input. And then later we'll be initializing a queue, and we'll be giving or appending the start node to the queue. And you can see like we have been using iterate or iterate while the queue is empty, or the loop function over here, in order to pop in or pop out the node which is visited. So yeah, that's a brief description about the data structure we used over here in the BFS. And coming to the next one about the greedy based first search. So greedy based first search is nothing but where the function f of n is equal to h of n. So the path will be defined based on the heuristic path. So we use mostly the priority queue and the array for, array for performing this operation, or which is nothing but the data structure we use, the priority queue and the array. In the first step, we converted the entire data into the dimensional array. You can see like the heuristic value of connecting nodes of A at index O into the array. So we have given the value or the heuristic of node A into the grid matrix of 0. So here the 0 will be indicated as A. So like in this way, we converted each grid or the specific position or the index of the given data into the array. I mean the 2D matrix or whatever the two-dimensional array. Then later we created or we defined specifically a greedy algorithm. So as per our requirements using the priority queue. So basically, yeah, you can see like we initialize a priority queue, and like starting nodes which are exporting the data array are given as given to the queue, like the visitor nodes which are will be given into the queue. So I can see I have been used basically one of the algorithm which I can say like the dimensional array, TT dimensional array. So TT is nothing but basically the nodes which we have been converted will be you can see like categorized into the alphabetically order. So like as per the rubric, we can see like whenever the two algorithms having the same heuristic value, the value with a lower or the low ascending must be chosen. So that's the reason we have been created or defined a specific function in order to choose or go for the low alphabetically order or low value. So like you can see like if it is already visited, the data, whatever the record will be stored over here. Like if the node is already visited, just keep it as a false. Like if it is visiting for the first time, like just keep it as a true. So basically, yeah, we you can see like the whatever the data input or everything has been converted into the array. You can run the code as well over here. Yeah, okay. Okay, the greedy based first search. You can see over the output. So you can see like the start node 0 is nothing but an A. You can give like a random number. So like a 2 is nothing but you can check over here. 1 second. Yeah, 2 is nothing but the node N. So once we run, we get a path greedy based purchase from node N. So like here each node like 0 indicates the A, 1 indicates the B. So it's in this way the algorithm works. And coming on to the same uniform curve search, the rest of the algorithms, whatever we use, everything is similar. We convert it into the two-dimensional array. We use the priority queue, and then as well as we use the array. Also we define like a specific class or functions, whatever as per our requirements. You can see over here we define queue. Queue is nothing but the naming convention. So basically this function works in such a way. The algorithm chooses in the ascending order, and the second one is about the queue cost, or this function will be working in such a way like the path will be chosen as per the cost value according to the cost value. So this is like a main algorithm. You can see like we have been developed this algorithm, this function using the priority queue. So basically most of the thing we use over is a priority queue. And the same coming to the start node, like a 0 indicates A. So whatever as per requirements, if you want A, we can give 0. If you want B, so as per you can check over here like a B at index 1. So like the B will be represented as the index 1. So yeah, that's basically about the uniform cost search. And the next one is about the A star search. So the same, like the A star has been done using the priority queue, and we converted the data into the 2D array, and we defined a classes as, we defined functions, or we wrote functions as per our requirements using the priority queue. Then later the start node and the goal node, as well as we converted the heuristic function, which of the h function, into the array form, as well as the input data is converted into the array. And once here we can get the output. So if we change like a node over here, I'm giving like a 2. So 2 is nothing but D. We can get the D, E, L, G. So the goal node is over here 5. So the 5 is nothing but the G. So as per our requirements, whatever it is. Yeah. So yeah, basically that's all about our data structure, what we have been used over in our queue. In our algorithms or DFSBS, whatever. Yeah, thank you very much, everyone, and thank you, Professor, for your support and guidance in this project. Thank you.